Here's a video on permutations. Now, you're going to probably see this written as NPR, where the P is a little bit bigger, and the N and the R are lowercase. So, and you'd find a value here and here. So the N value in this case is 5, and the R value is 3, and you're going to use this formula. I really should actually put this in parentheses because you have to do the subtraction first. So in this particular problem, we're going to put 5 factorial on the top, and then 5 minus 3 in parentheses, factorial in the bottom. We've got a little bit of work to do to the bottom. 5 minus 3 is 2. And then if you've already seen the video on n factorial, you know that that's n times n minus 1 times n minus 2 all the way down to 1. So the top value here is 5 times 4 times 3 times 2 times 1. And the bottom is 2 times 1. And inevitably, in these problems, all of the bottom will cancel with part of the top. And you end up getting, in this case, 5 times 4 times 3, which is 60. On this problem, 10, I'm going to use a different color. So that it stands out, I'll use like a lighter purple. So equals 10 factorial over, when I have students start this, I have them actually write the 10 minus 4, or in the previous problem, 5 minus 3, in the actual problem. Even though I know you can subtract, I want to know how you're getting that. Otherwise, how am I supposed to figure out if you're doing it correctly? So 10 minus 4, then we do our subtraction. 10 times 9 times 8 times 7 times. I'm going to shorten this up a little bit because I don't want to write all of that stuff. Right? If I wrote out 6 times 5 times 4 times 3 times 2 times 1, it would take a lot of time and a lot of space. And since I already know that all of this will be canceled by all of this, I don't have to write each of them out, saving me valuable time. And I'm looking to do 10 times 9 times 8 times 7. And most of the time I'm going to be fine if kids use a calculator on this sort of thing. So 10 times 9 times 8 times 7 is 5,040. So that is number of items, 10 items taken 4 at a time. So what is this used for? Well, here's a specific example. It says, how many ways are there of 12 runners finishing first, second, and third in a race? Now, the reason why this is important is if you're the person in second and you finished a second or two behind the person in first, you wish you had tried a little harder. And the point of me saying that is the order matters. Okay? So you have to think about the situation. Does the order of the grouping matter? In this case, first, second, or third, the order is very important. Okay? Other instances, we'll do a couple more after we do this problem, would be like maybe a telephone number or a license plate, things like that. Order matters, right? The phone number 7243892, if you jumble those numbers up, it's a different phone number, therefore order matters. So let's just do this problem and let's see if we can set it up. So the fact that order matters here tells me that it's a permutation. And I'm going to look for the large number in the problem. That's the 12. That is n. So that goes in front. And then the number of items that I'm selecting, if you will, would be, in this case, 3. So we've got the permutation set up. We're going to now use the formula. Again, it's n factorial over n minus r in parentheses factorial. So the top number is 12 factorial. And at this point, if you're comfortable doing the subtraction, you know that 12 minus 3 is 9. You can jump right to 9 factorial here. If you prefer going step by step, by all means do that. Okay, so the 12 minus 3 is the 9. 12, 11, 10. 9 factorial will cancel the 9 factorial. So it's really not a lot of math to do here. 12 times 11 times 10, and that's 132 times 10, or 1,320. So 1,320 different ways of writing the first, second, and third place finishers out of a group of only 12 people. So it's pretty staggering if you think back to the fundamental counting principle. If we had to write all of those different combinations out for our sample space, it would take us a great deal of time to come up with that 13